Okay guys, today we're going to talk about the climate of the area. And so it's very important to note that weather is a short-term conditions. We talk about it being sunny or hot or cold or windy or raining. Even if those are specific, it's 100 degrees today. Climate is long-term. These are taking 30-year averages. These are taking extreme cold, extreme heat. It's factoring everything together, coming up with the average. And so some areas have good 30 years worth of data. Some areas have much longer data. It depends on how long your city's been there. The issue too is, let's say you were in Phoenix and you have more than 100 years of data. When Phoenix was a tiny little farming community as opposed to a giant metropolis it is now, we find that the 100-year data is a little skewed. So we like to use the last 30 years to help with understanding climate of the area. Arizona is so diverse. You guys are in a number of diverse places and you guys might be across Arizona. So we're going to talk about all of it here today and in the impacts of horticulture. So microclimates, forget all the diversity of topography and water versus no water and open deserts and high mountains. Forget that. Talk about just the microclimate for a second. Even within a specific area, there's both man-made microclimates and there's naturally occurring situations that lead to microclimates which are unique within the specific climate. We'll talk about some of those. Some of those microclimates could be just tree lines, tree breaks, planting on the north side of the house versus planting on the south side of the house, planting down in a drainage versus on a hilltop. And that's not taking into account the urban heat island effect of cities and such. So microclimate is pretty interesting. So again, the USDA uses the last 30 years for their 1 to 10 zones. And it takes the average annual extreme minimum temperature over a 30-year period. It just looks at that one factor, what was the coldest temperature that achieved, and then it averages it. What is that average coldest? So that's not the all-time coldest, it's the average. And so we have to be careful too. If we choose plants that are good for our zone is taking into account the average. We have to keep in mind and know our area, what is the extreme cold that it can get to, and will those plants die? Will they recover? And this has to do with plants that grow for a long time. That's definitely a factor. You get hardiness zones when you buy plants at your local nursery and such. But also if you're in Flagstaff versus in Yuma, and you're planting annuals or seasonal vegetable gardens, the climate zone isn't as important. It's more important to know when your last freeze date is so that you can move forward with warm season planting. So there's some nuances there. Places, speaking of low deserts, places like Yuma and Phoenix rarely drop below freezing, and they would be considered a zone 10 in the USDA scale. Flagstaff, the White Mountain communities, they can have temperatures, and along the Mogollon Rim, they can have temperatures that drop on average to -10 to -20 every winter. So they're in about the zone 4, zone 5 range in the hardiness setup. And so you can see already Arizona is quite different from -20 in the winter to barely at freezing in the winter, and we're talking Fahrenheit. You can find detailed information. Let's say you just have a thermometer on the back porch. That's not gonna keep accurately a record of that data, and it may not be calibrated correctly. So check out some Wonderground sites. Citizen scientists in the area with good recording equipment have signed up to have their data uploaded onto the internet live. And so that's on Wonderground. Our Chino Valley Agribusiness Center has data going onto Wonderground. The Vineyard at Yavapai College in Clarkdale has their data going onto the Wonderground site. And just in those two locations within a 5-mile radius, there's 10 or 15 sites in Chino Valley. There's 10 or 15 sites in Clarkdale, and anywhere in between, check out Wonderground sites to look specifically for your temperatures and your averages. And there's a lot more about humidity and such there that you can find. So think about Chino Valley, Prescott Valley. We are in a zone 7B, and I say 7B because USDA hardiness zones for each number, that's a 10-degree swing, that's a 10-degree variation in average low temperature, average extreme low temperature. A and B breaks it down to 5 minutes, or 5 degrees. So that 5 degree difference is even a more fine-tuned specific um, low temperature. And so Prescott Chino, Prescott Valley 7B. That's a great average for our area. The Verde Valley is a climate zone 8 for the most part, but the Verde is super diverse. People in Sedona say they're in the Verde, people in Jerome, people in Camp Verde, people in Rimrock. The Verde Valley is pretty big, and extreme elevation differences from one end to the other create a lot of microclimates within. And so there's a lot of cold air drainage happening because of the topography in that area. And so those of you that know, and this is a great example, Camp Verde. Camp Verde is on the lowest end, kind of the southeast corner of the Verde Valley. It gets the hottest summertime temperatures in a lot of northern Arizona, short of the bottom of the Grand Canyon and way over by the Colorado River. The Camp Verde area is extremely hot because the elevation is low in northern Arizona. And so the temperatures warm up quickly. However, being at a higher elevation where there's a lot of topography around there, cold air drains in the wintertime. And so cold air can settle down in the Camp Verde area. So lucky you, hottest daytime temperatures in the summer in the Verde Valley, and you have the coldest wintertime temperatures in the Verde Valley. And so it's kind of the reverse. As we think of Flagstaff as higher in elevation, it gets colder. For every about 1,000 feet in elevation you go up, the temperature usually drops 3 to 4 degrees. But in cold, clear nights where cold air is settling, the opposite occurs. So down in the high elevation basins, cold air can settle, and that could be quite hard for a place that's warming up quickly, but cooling down quickly in the night as cold air pools there. And so be careful, know your area. I like to think in the Prescott area, Chino Valley suffers the same kind of way within the Zone 7B. Prescott, the climate's a little more moderate. It's cooler in the summer because the elevation is higher, but it's a little warmer in the winter because cold air drains away from it. The topography and the way the air flows is very interesting, and your specific area may be different. Some areas of the foothills around Jerome, around Clarkdale, haven't recorded temperatures much less than 20 degrees, and they're up above 5,000 feet. Where you can go to other areas in Arizona above 5,000 feet, Ash Fork, Seligman, high basins, where the temperatures are below zero every single winter. And so below zero versus 20 degrees just because of cold air draining off. And so it's pretty interesting, and again, you got to know your area. I was in college in Tucson. I'm a U of A Wildcat, and I got to work at a local nursery. And I always had to ask people where they live, where were they planting, where were they growing? Because again, downtown Tucson rarely freezes. You can grow almost semi-tropical plants in downtown Tucson. Palm trees, ficus trees, citrus trees. Those are common things for specific areas in Tucson. You move outskirts, Tucson's not as big a metropolis as Phoenix. You move to the outskirts pretty quickly, and maybe just a couple miles east, west, north, south. You get into the more rural areas or more be agricultural areas where the radiational cooling, evaporation happens quickly. Those areas cool off quicker than the downtown area, and they can experience freezes when it doesn't freeze downtown. And so if you live along a river drainage, they call them rivers in Arizona. This would be like a dry wash drainage, maybe the Santa Cruz, the Relito River, any of those coming off of the Catalinas. Those drainages pool cold air. And so if you're trying to plant a citrus tree and you live on the banks of the Santa Cruz River, you could drop into the teens when it may be 40 degrees downtown or 35 degrees downtown. And so the difference within a climate zone in certain specific instances can be 10 or 15 degrees difference in temperatures. So that difference can make the difference between what you can grow and what you can't. So let's talk about heat. So in the low deserts, temperatures can range from 110, and in the mountains it could be in the 70s or 80s. That's why everybody flocks away from the low deserts and goes to the mountains in the summer. Flagstaff potentially could be 70 or 80 degrees. Prescott, an average high in the summer, 80 to 90 degrees. Cottonwood could be 90 to 100. Phoenix could be 100 to 110. That's kind of an oversimplification, but you guys have done it, you know it, you've traversed between these places, and you just know what range they fall in. And again, if you start doing elevation plus 3-4 degrees for every 1,000 feet, you can deduce these same temperatures. As you can tell, the implications for freeze and heat, depending on variety, are extreme. And so we have a diverse area, and it's good to plan. Dry air leads to high sun intensity. Dry air leads to large diurnal swings. Diurnal swing is the difference between daytime temperature and nighttime temperature. Diurnal temperature can be great for fruit trees and for grapes. It can be very complicated for other crops, especially when in the high deserts you can have temperatures as warm as 80 in the day and still dropping below freezing at night. Um, I have a student who has a vineyard in Springerville, and he recorded a temperature of 86 degrees on a night where the morning low was 19. For some places in the world, or at least in the United States, they would say summer, winter. That's like extreme summer, that's extreme winter. Plants don't like that for the most part. And if you look at native plants, our native plants are highly adapted to those types of things, leathery leaves, small leaves. When we start bringing in plants from other parts of the world and ask them to grow in an agricultural setting and give them that type of extreme on the same day, it's very confusing, and you have to be prepared for that. If you already live in that area, you can modify, you can add season extenders. If you're looking to choose agricultural property or just a good homestead type area, maybe you pick your area a little bit better, or at least know what fights you're going to have to fight. Another website that I like to recommend is rainlog.org. As we start to talk about rainfall and precipitation, local citizen scientists with good rain log data collection, precipitation collection, put that out. It gets updated at 7 a.m. every morning, and there's quite a few of them across the area, across Arizona. Rainfall averages from a few inches a year to 30 plus inches in our eastern mountains. The Flagstaff area could be around 20 inches, the mountains in Prescott up to 20 inches. Verde Valley is usually 10, 12, 15, 16 inches a year. Again, it's highly dependent on elevation. The higher you go in elevation, the more the air rises, forms clouds, and squeezes out every drop of precipitation that can occur. Winter precipitation versus summer monsoon is very distinctive. The summer monsoon sets up like this. Okay, this will be opposite for you, but if this is California, this is Arizona, this is New Mexico, as it starts to heat up in Arizona and it gets hotter and hotter, we have to suffer a little bit. The air pattern is kind of coming in from the west. The more we suffer, a high pressure starts to set up over New Mexico, and high pressure goes clockwise around it. So as it's going clockwise, the air starts to spin around the high pressure. If that high pressure sets up right over New Mexico, southern Colorado, as it starts to spin, it starts to pull moisture from the Gulf of Mexico and south in Mexico and transport it into southeastern Arizona. At the same time, if we're really suffering with heat, a thermal heat low sets up around the Yuma area, and that thermal heat low is, here's the low, and the air is moving counterclockwise around that. And as that starts to strengthen, it starts to pull. If you think about the high and the low pulling, you get this moisture transport from south to north or from southeast to northeast, and it's just sending moisture from the Gulf of California, maybe even the Pacific, Gulf of California specifically, Mexico and Gulf of Mexico into Arizona. Add to that some tropical disturbances that get pulled up into Arizona, and we can have moisture that just kind of cycles around in the daily heating. That's why we say afternoon thunderstorms. As it starts to heat up in the day, the air rises, thunderstorms build over the mountains first, outflow boundaries come out from those thunderstorms, especially when they fall apart. If outflows move in and collide, new storms build, and it becomes very sporadic. It's hard to anticipate, but the higher your elevation is, the more likely, and the averages say you get more precipitation. The further east you get, the more monsoon precipitation you get in Arizona at least, and southeast, definitely those higher mountains in southeastern Arizona. Contrasting with that is our winter precipitation. Cold fronts come in from the west, and it's either from the northwest or from the southwest, and that winter precipitation is more predictable. If it comes in over land, it's going to be drier. If it comes in off the Pacific and sets up over the Pacific and spends some time there, it'll pull some moisture into Arizona. The more southerly trajectory, the more potential for precipitation in the form of rain. The more northerly, more northern Arizona is going to get snowfall. And so the drier, colder it is, the more likely for snowfall, but the amounts are limited by cold air because the more moisture from the south, the warmer air is transported in. So it's kind of a unique setup for Arizona. Again, that cold fronts can be predicted because they march, they move. A low pressure system pulling a cold front moves across Arizona, and we can say, hey, 2 days out, 3 days out, it's going to potentially rain or snow. We have dry periods in the spring and fall, and so the spring dry period is very distinct. The fall dry period can be usually through October. The fall's a little tricky too because sometimes the monsoon goes away fast and winter precipitation doesn't set up until maybe November or December. Sometimes there's this carryover or like a merging, and it can be pretty intense in the fall if there's still moisture coming up from the south and cold fronts come in and interact with that. There's a period of time where it tends to be drier, but if that setup occurs, it can pull extra moisture and work on it like cold fronts and almost monsoon moisture at kind of September, October timeframe. Add some tropical disturbances working around down in there, and we can sometimes have a good, decent fall moisture season. Wind is always an issue. Spring winds are the worst. Those cold fronts that come across, as they start to run out of moisture, they start to act on warm air in the day, and they start to just blow. The winds just blow. Think about windbreaks, plant your own windbreaks, and think about how you can grow your crops with a little protection. So another thing we're going to talk about is degree growing days and winter chill. Degree growing days are important for vines and grapes. Degree growing days are weird. You can use degree growing days to predict insect attacks. For instance, blister beetles, grasshoppers, squash bugs can all be predicted scientifically by temperatures and when these things will emerge. Insects are very tied to temperature and when they come out. Again, going back to the USDA hardiness, if we're in a zone 7B, I'm in a zone 7B, my campus where I teach agriculture is in the zone 7B, that is the same as Richmond, Virginia is in the 7B. So not all, even though we get the same low temperature on average in the winter, nothing else is the same. Our precipitation, our moisture regimes, just what it's like to grow in those climates, the soil is completely different. So USDA zone is important for choosing plants, but it's not the end of the line for knowing how to grow in your area. Grapes like to use a Winkler scale. We use a Winkler scale to help us decide which types of grapes to choose. Different varieties. If you're in the Rhine River Valley of Germany and you're going to grow grapes, that's different than the grapes you're going to grow in Perth, Australia. So Perth, Australia would be like a zone 5 in a Winkler scale. The Rhine River Valley of Germany would be in a zone 1. We even have vineyards in Arizona, just west of Flagstaff. There's one called Wagon Wheel Vineyard that's up above 7,000 feet. And so the types of grapes chosen for there aren't the same as the Central Valley of California, for instance. So chill hours are important. Fruit trees have a calculated number of chill hours until a tree can bloom. Again, the USDA zone is of less importance because an apple tree can grow in Phoenix and Yuma, and an apple tree can grow at our highest elevations in Flagstaff. It's not the cold temperature, it's when it blooms is critical. People often say, my fruit tree is not setting fruit. They're not realizing that it's 70 in the day and 25 at night. They might not be experiencing that 25 at night because they get up later. They're not out seeing the fruit tree blooms like just freezing and dying. So the winter chill is important. It's a number of hours between 32 degrees and 45 degrees. So it's not frozen and dormant. it's dormant but not actively growing. Actively growing starts above 45 degrees or so. If it stays above 45, the tree starts to initiate. So that time between 32 and 45 degrees is important. And again, those number of hours in our low deserts aren't the same as the hours in our higher elevations and anywhere in between. And so winter chill in our area is between 200 to 300 hours all the way up to 1,000 hours or more. And all that means is low chill hours would be required in Phoenix. They have a short amount of chill hours. It starts to warm up. Those plants initiate a response. They bloom out, and it's okay. They can progress with spring, with fruit, and that stuff can get harvested before it's 110 degrees out. In the higher mountains, things can't bloom out. If you chose the same low chill variety and planted it, the tree would survive, but it would bloom out in the spring too early. The first warm day in February, it would have met those 200 to 300 hour chill hours, and it would bloom out, and the freeze would always get it every single year. And so in our area, we're doing a lot of research. We do a lot of grafting at YC. You guys would do grafting as a part of the program. We're always looking for varieties that can bloom out a little bit later. We don't want it so late that then we get into the heat issues, or so late that when we get an October freeze, the apples, the peaches, the pears, the plums, they're not ready yet still. And so think about winter chill, the implications, and we'll do some calculations for those. Thank you.